That's a good way to draw a crowd. Oh, sure. Yeah.
I'm gonna intro yours. And then when do you want to do the?
It's gonna be at the end.
Okay. Did you want I don't know if you want to.
Yeah, it doesn't matter. I can just use the podium mic.
Okay. Because I was wondering if when you wanted to.
I
explain.
did, yeah.
I know, so-
I like it nice and cold. Our studio is like 65 degrees. It's beautiful. So this is like warm for me. Oh, am I disappearing? Okay. Well, but
Yeah, that's
yeah. You silly visual guys. Trying to make us look good. What are you doing? Yeah, no problem.
Like I'll just mute them, and then if you want to use one, just tap the. Turn that down a little bit too.
Like give it a couple minutes.
That's
People
fine.
trickle in.
Yeah, no rush at all.
This guy's still on. Cool.
And the weather talk, right? There's a good line out there. That's good.
Yeah, it is good. Well, the pizza helps.
Do you always have lunch when you do events like this? Or?
Typically.
That's great.
Yeah. Try to bring in the food.
Yeah. What kind of speakers do you have? Like,
Well, I mean, we've had other community speakers. Now I haven't been here that long, but the university in general will have people come to sing at Fort Worth to speak. Sometimes I think one time we had the mayor come and speak. So we'll get some local figures, executive figures to come and talk to us. I'll be right back. Sure. online as far as streaming, and then we'll go ahead and get started.
Sure. Yeah.
We're good. Good morning. Good afternoon, everyone. Thank you all for coming today for our first event in our Culture of Preparedness series. And, you know, kind of coincidentally, today we're talking about severe weather. We just had, of course, an ice event yesterday, and we, you know, managed to make it through that. So I'm glad it wasn't as bad as it could have been. Again, my name is Blake Abbe. I am the emergency manager with the safety office here at the university. And today we're going to provide you with information on severe weather, as this marks the beginning of Severe Weather Awareness Week here in Texas. And before we get started, though, I'd like to thank our sponsors for helping put on this event, CBS 11, Hyzen's Nizza Pizza, and UNTHSC Technologies. We couldn't have put on this event without them, so please give a hand for our sponsors. So today we're going to provide you valuable information about severe weather and how you can be better prepared here at the university. And at the end of the event, or at the end of the presentation, we'll have a special demonstration of our new alert beacons. And we're really excited to have those, and we'll show you what they can do. So to start off our event today, CBS 11's Chief Meteorologist, Larry Mowry, will give a presentation about severe weather in North Texas. So everyone, please give a warm welcome to Larry Mowry.
Thank you, Blake. Thank you. Well, thank you all for having me here today. It's a great day to talk about the weather, right? I mean, how crazy was this weekend? It was 80 on Saturday and 20s yesterday afternoon, and today we'll probably stay below freezing as well. So, you know, a lot of weather happens here in Texas, and I have what I consider probably to be the best job because the weather's always changing here in Texas, and it never gets boring, that's for sure. And this weekend was one of those examples of how wild the weather can be. But I thank you for having me. I am the Chief Meteorologist at CBS 11, and our station is actually still here in Fort Worth. A lot of the other stations have moved out of Fort Worth over to Dallas. They started in Dallas too. But we're right in Fort Worth. We're just east of downtown along I-30. If you ever travel I-30, you see the one pillar sitting up there that has CBS 11 and TXA 21 on it. Funny story about that. When the building was built back in the 50s, they commissioned this tower. And so they built the one little like spear that sticks up from the ground. Well, originally there were going to be two because we're Channel 11. They ran out of money and could only build one. So we just have one little spear there. But it'd been pretty cool to see the two ones up there to make an 11. But so I work at Channel 11. It's a great place to work. We have such a wonderful crew of people, and we're all really committed to our jobs about public safety and getting awareness out in news and weather and sports and so forth. And so I feel real blessed to work at the station I work at. I do have to say, though, that because this is a severe weather talk and an awareness week, I do have to say that in the event of a tornado warning today, it's likely not going to happen. I guarantee it's not going to happen. But in the event of a tornado warning, we all need to go to Cowboy Stadium because there's no chance of a touchdown there. All right? That's my go-to weather joke. So we'll see. Next year, well, I don't know. So again, so what we're going to do today is we're going to have a little fun, and I'm going to go through some information about severe weather. And initially, I was not going to include much about winter weather, but given the events of the weekend, I threw a little bit of winter weather stuff into my presentation. So we'll kind of go through this, and if you have any questions during my presentation, this will be very informal. Just raise your hand and shout it out, and we'll go from there. But at the end, I'll also take some questions as well. Now, I am the Chief Meteorologist at Channel 11, and I've been with Channel 11 for 6 years now. I got my meteorology degree at Valparaiso University. Has anyone heard of it? Handful of people. Good. They were great in basketball back in the 90s. They made it to the Sweet 16. But Valparaiso is in Indiana. It's just outside of Chicago, just across the state line. And it's a really small school, but they've got a wonderful meteorology program. One of the other meteorologists who actually was in school when I was in school was Ginger Z at Good Morning America now. She's the new weather person on Good Morning America. So Valpo is a great place. I love the school, and I always talk about it whenever I go speak to folks. So you can follow me on Twitter at CBS11Larry or my Facebook page, CBS11 Weather. And we're constantly putting information out there on Twitter and Facebook. So I thought I would start with just a look at the drought and how bad it's been. So here are the lake levels and the departure from conservation stage. All the lakes here in North Texas are below normal values. You can see Lake Lavon's down 12 feet, Grapevine Lake's down 9 feet, Lake Pat Cleburne's down about 7 feet. And then some of the outer lakes around the Metroplex, Cooper Lake's down 12. Look at Lake Bridgeport, down 20 feet. Last week, I went up to Wichita Falls. And is anybody from Wichita Falls? No? Okay. Oh, yeah, I got one. All right. They're running out of water in Wichita Falls, and it is really, really bad there. Their lake, where they get their water, is only 26% full. That's it. Most of our lakes are about 60 to 70% full, so to give you some comparison. So what Wichita Falls is doing is they're taking sewer water, treating it, and putting it right back into the tap. They're not even, most cities, when they take their sewer water, they treat it, then they dump it back into the river or a reservoir, and it goes through the natural process of Mother Nature helping clean it up. They can't do that in Wichita Falls. They're so desperate for water, they're taking that step out and basically taking it right out of the sewer, treating it, and dumping it right back into the tap. And they're going to get 5 million gallons of water a day in that process. So it's really amazing how bad the drought is up there. We've been pretty fortunate because we've had some rain events in the past year or so that have helped out, but we still need some rain. We're still pretty desperate for rain. And this kind of really illustrates just how bad it's been for the past 4 years. So back in 2009, we had 40 inches of rain. Our average is about 36 inches at DFW. So over the past 4 years, we have run a deficit. 2010, we were down to 31. 2011 was really bad at only 25 inches. That was the hot summer, too. Remember the hot summer with all those 100-degree days? And then 2012 and obviously 2013 was not a good year either. So we need some rain. The good news, if there is good news in this, is that we're entering what is typically our wet season, which is the springtime. So you can see in spring, we average about 11.5 to 12 inches of rain during spring. And spring is considered to be March, April, May. So it's not the astronomical spring, which you hear about the equinoxes and the solstices and so forth. This is meteorological spring, which is March, April, and May. So hopefully we get a good soaking here in spring. The way it's looking now, not great. I mean, we're probably going to get some rain events, but I don't think we're going to see a huge surplus over 11 inches of rain this spring. We really, really do need that. And of course, we're coming out of what is the dry season. Wintertime. Most people think summertime is the dry season, right? It's so hot and dry usually in the summer. Well, winter's drier than summer on average. And the main reason for that is in summertime, you can occasionally get a thunderstorm that may produce a quick inch of rain, and that skews the averages up in the summer compared to the wintertime. Now, for instance, the rain we had yesterday and the sleet and all that, that equaled about 1/10 of an inch of precipitation. That was it. So even though it was kind of drizzly and rainy most of the day, didn't add up very much. And that's the thing about winter precipitation too. Sleet and snow, if you get an inch of snow, that's not an inch of water. That's usually about 1/10 of an inch of water. So there's winter precipitation, yeah, we'll take it. We'll take whatever we can get, but it doesn't really fill up the rain buckets that much. So with that, as we get into spring season, the biggest threat we have here is obviously severe thunderstorms and tornadoes. So oftentimes when you'll hear me on the air say, we've got a severe thunderstorm warning, and we use that word severe as a benchmark for just how bad the storm is. And there are really only 3 criteria to make a storm severe, and it has nothing to do with lightning or rainfall, anything like that. It has to do with the wind and the hail. So if you look at the definition of a severe storm, in order for a storm to be considered severe, it has to be capable of producing hail 1 inch or larger. That's about the size of a quarter. If it produces hail 1/2 inch in size, and you may have hail for 20 minutes, unless it reaches that 1 inch criteria, it's not considered a severe storm. It's severe to you though. That's what's silly about being a weather meteorologist is we use all these special ways to classify things, but it doesn't often apply to the regular person who's experiencing the weather. So, hail 1 inch or larger is the definition of a severe thunderstorm. Winds greater than 58 miles per hour is the other classification that makes a storm severe. So if we have a storm that's coming through Tarrant County heading through Fort Worth, we'll use our radars, we'll look at spotter information that's coming in, and we'll determine, okay, is this storm capable of producing 1 inch hail or 58 mile per hour winds? And oftentimes, the warning will come out before this is actually happening, because obviously we want to give people a little lead time as to whether or not we'll have high winds or hail. Oftentimes, though, the storm never really reaches that max potential, but it will still have a warning with it. So there is a little leeway in the warning process with the severe weather, but if you hear the word severe thunderstorm warning, two things can happen. You're either going to get really large hail, possibly up to 1 inch or greater, or winds close to 60 miles per hour. So when you hear the word severe thunderstorm, think to yourself, okay, it's going to be either large hail or high wind that could impact me. The rain, yeah, you're going to get a lot of rain. You're going to see a lot of lightning. But the hail and the wind make a storm severe. The other one, obviously, is or it's producing a tornado. And if that's the case, we get a tornado warning. So, really, the three criteria are just winds and hail, and then the third one ratchets up the warning to a tornado warning. So one thing I always like to talk about when I talk to groups is how confusing we are in the weather world, because we use all these watches and warnings and advisories and all this silly talk to kind of explain the weather, and oftentimes we're not very good at explaining it to people who are watching because we throw out all these terms all the time. So a watch and a warning. Now, a watch is not as bad as a warning. A warning is worse, all right? So whenever you hear warning, that's when things are bad. That's when things are really happening. A watch means that, okay, I just need to watch to see what's going to happen because something could happen in the future. So a watch is basically be alert for the potential for severe weather. Now, watches are displayed on a map differently than warnings. Watches take up larger areas. Several counties, many counties, pretty large parts of states will make up watches. So here's an example of a severe thunderstorm watch. And you can see out to the west, all those counties shaded in yellow were under this severe thunderstorm watch. So they take up multiple counties. And when we show them on TV, they're usually shaded in like this. Sometimes we'll outline them in a box. But you can see just how big the area is that's under the severe thunderstorm watch. Now the warning is, take action. Something's coming your way. There is a storm. It's strong enough to produce either hail or high winds, and it's strong enough where we have given it a warning. So you need to take action if you're in that warning area. And here's an example of 3 different storms that were severe, and you can see the outline of the box representing the area that was under the warning. This, by the way, was the big hailstorm that went through Dallas a couple of years ago. I've got some pictures coming up to show you. Was anybody over in downtown Dallas or just east of Dallas when that happened? It was a huge hailstorm, billions of dollars of damage a couple of years ago there in Dallas. So you can see the outline is mainly roughly by a county. Now, what we used to do just about 10 years ago, they used to issue warnings for the whole county. So this storm that was, say, up here, up in far, far northeast Dallas County, it used to be that if we were going to warn for that storm, we would issue a warning. Is that me? Is that me? Oh, this is Tom Ream. He's our photographer at CBS 11. So it used to be that when we would issue a warning for this storm, if it was right here, they would issue a warning for the entire county, which doesn't make any sense because if you live over here in West Dallas, that storm's not even going to get close to you. So now what they've done is they've broken it down into portions of counties. So you'll often see a warning come out for Dallas County, but it may only include the far northeastern part of Dallas County. And that's really a nice benefit and a nice perk that we've done over the past couple of years to highlight the warnings. So again, tornado watch is the same as a severe thunderstorm watch. just be alert. The possibility is there that we could have storms that produce tornadoes in the future. A tornado warning is where we've got to take action now because a storm that is possibly producing a tornado is heading your way. And the tornado watch looks very simply much like the severe thunderstorm watch. A big outline of counties shaded in red or drawn in a box. Now this is the warning. The warning looks just like the severe thunderstorm warning, but we kind of outline it in red. And this storm is heading towards Denton there with a tornado associated with it. So it goes back to the definition of a severe storm. The hail 1 inch or larger, the winds 58 miles per hour or greater, or it's producing a tornado. So that's kind of the key definition here when it comes to severe weather. So let's talk about how we get severe weather and what generates severe weather. So how many have seen beautiful looking storms? Do you guys think storms are beautiful? Yeah, some people do. They're scary, but they really are beautiful to see. I had a class when I was at Valpo where we actually went storm chasing. And we actually got credit for this class. It was really wonderful. And we spent 2 weeks chasing storms around the Great Plains. And what you see and learn by being out there is really just phenomenal. It's really amazing stuff. And the structure that I have here of this supercell thunderstorm is pretty much what you would see if you were out there looking at this storm out in the field. So how a storm works is, I'm going to take my jacket off. I'm in a nice, cool studio where it's like 66 degrees. So, and here it's warm to me. So, okay, so here's how this works, all right? So as you know, hot air rises and cold air sinks, right? You know that in your house, right? Usually if you have a second floor, it's usually hotter up there than it is on the first floor. Same thing happens in the atmosphere. Air is always moving. You have hot air that rises and cold air that sinks. That's how a thunderstorm operates as well. You have a pocket of hot air that goes up into the sky, it forms a cloud, and then it comes back down as colder air. So you've got this process where warm air is going up and cold air is going down. And that generates the thunderstorm. Well, obviously, as you go up into the atmosphere, temperatures cool. And there comes a point where temperatures drop below freezing. Even in the heat of summer, at some point just above us, temperatures are below freezing. So what happens with these thunderstorms is you get the air that's rising. And as that air rises, the raindrops that form in the cloud get above the area where temperatures are below freezing. And so those raindrops, they start to freeze together and they form hail. And what happens there is that hail gets bigger and bigger as it's going up and down in what we call the updraft. And that's where the air is going up. Eventually, those hailstones get blown out of the updraft or they get too big and then they fall down where the air is coming down. And that's what generates the hail. So basically, with all this air going up into the sky, the hail gets bigger and bigger and bigger until it cannot be supported by that air that's keeping it up in the thunderstorm, and then it falls to the ground as hail. Now, the size of the hailstones are dependent on how fast that air is going up into the thunderstorm. Any guesses on how fast air can go up into a thunderstorm? Anybody want to take a wild guess? 120? That's a good guess. It's pretty much right on target, too. In fact, it can go a lot faster than 120. But to get baseball-sized hail, has anybody seen baseball-sized hail? Yeah? How many have replaced roofs in the past couple of years? Yeah? That's it? Just a handful of you? Wow. I've done mine twice already in the 6 years I've lived here. So you got the hail that comes up. So to get baseball-sized hail, the air that's going up into the sky has to be going at over 100 miles per hour. So to keep that hailstone in the sky long enough where it can grow big enough to reach baseball size, the air, and think about this, the air that's starting down here at the ground has to go and accelerate up into the sky at 100 miles per hour. That's incredibly fast. I mean, that's moving air right there. But it's because of the atmosphere heating and cooling and the whole process of that air moving. So to get that hail up to baseball size, you need updrafts of 100 miles per hour or greater. And this was that Dallas hailstorm a couple of years ago, back on June 13th of 2012. We had about grapefruit size hail. So if it takes 100 miles per hour to keep a baseball up there, to keep this up there, you're probably looking at about 150 miles per hour, maybe even greater. There's no way to get an accurate measurement of just how fast that air has to be to keep something up like that up in the sky. But what's really interesting is about these big hailstones, you can see they're just multiple hailstones kind of melted or frozen together. And that's what happens up there. You get all those hailstones clicking around and they come together, they break apart, and then they fall down. What's really neat about hailstorms too is they're tremendous lightning producers as well. Because what happens up there, those hailstones that are bouncing off of each other generate electricity. And sometimes they generate different charges that create more lightning. Oftentimes when you have a huge hailstorm, you'll get a tremendous amount of lightning. Not only cloud to ground lightning, but within the cloud itself. And there are two different types of lightning. There's lightning that occurs just up in the clouds, and there's lightning that occurs from the clouds down to the ground. The vast majority of lightning actually occurs up in the clouds. But oftentimes we'll get the cloud to ground lightning as well, and that's obviously the most dangerous if you're outside during a thunderstorm. And you never really want to be outside during a thunderstorm because of the lightning or the hail or the high winds. But I've got some pictures here of these hailstones from the Dallas storm. So this is this happens yeah, this is a nightmare for car dealerships too. Every car dealership here in North Texas has a tremendous amount of hail insurance when it comes to their fleet of cars. But this is, there have been, in the 6 years I've been here, there have probably been about, if I had to guesstimate, about 5 hailstorms in the Metroplex where we've had storms that have knocked windshields out of cars. So it happens, and you really have to be cautious when you're driving and you get stuck in a thunderstorm, because this is obviously not the place to be when you're in a thunderstorm that's producing baseball-sized hail. There's another example of that. So this picture here, I think, is a wonderful picture because it really shows the power of the storm, but also how something happens that you wouldn't think would happen. Because here is a vertical window. It's not flat like your car windshield, and yet it's broken out because of the hail. You know, I always say that when you hear a tornado warning, what's the first thing you do? Go look outside. That's right. You go look out the window. I do it. I mean, I'm not going to pretend that doesn't happen, but it's so true. I mean, the minute you hear there's a tornado warning, oh, let's go see. Let's see what's happening. Yeah, it's exactly what we do, and it's just because of the curiosity and, well, I need proof that this is actually happening. One of the most dangerous things to do in a hailstorm or in a tornado, for that matter, is to go look at the window, because you never know when you'll get a hailstone that's being blown by the wind right into your window. And if somebody was standing there, they're obviously in bad shape. So, you know, we tell people not to go look, or, you know, to stay away from the windows, even during severe thunderstorms, and that's why, because we don't want people to get hurt by the blowing hail. And you never know when it could happen too, because out of the blue, you could maybe get a hailstone big enough to knock out your window, even though at that moment it wasn't exactly hailing. So I just love that picture because it really illustrates the point. So we've got the hail, and then we've got the winds that come with thunderstorms as well. And there are different types of winds that are generated by thunderstorms. One of them is by a collapsing thunderstorm. And this actually happens a lot in summertime here. So we'll get a thunderstorm that bubbles up during the heating of the day, and then once the heating goes away, the storm collapses on itself. And as that happens, it's really almost magical to look at, because you'll see the beautiful structure of the supercell thunderstorm, and then all of a sudden the clouds just start shrinking, and it just collapses. And you can actually see it happen in the clouds. So the cloud will be real strong and real thick down at the bottom, and all of a sudden it starts to look more like a wispy cloud, and it just starts collapsing on itself. Those things can produce real high winds, and it happens, you know, quite frequently in the summer. So as that storm collapses, you could get winds greater than 60 miles per hour, and you'll usually get a big burst of rain and high winds, and then that's it, and it's over. The other really cool thing that happens here in the summertime when we get a big thunderstorm collapse, we get these heat bursts. Has anybody ever heard of a heat burst before? So a heat burst is what happens as air sinks, it warms, okay? So air that goes up into the sky cools, air that sinks actually warms. It's the natural compression of pressure. So as that air comes down, it warms. There have been cases where air that was in the thunderstorm sank and warmed so much that it singed the ground. It was actually in Texas here, where in the cotton fields, it was down by Waco. And I believe it was in the 40s. There was a thunderstorm, and it was late evening after the sun had gone down, and the storm collapsed on itself. And the air sank so fast and was starting so high that the temperature got up to about 140 degrees. And it singed the cotton fields. And people had no idea what was going on. They were just, what happened? And it was just amazing. And you should look that up if you can online, because there's a lot of documentation about it. But these heat bursts are really amazing, because I've seen them happen here where we'll go from about 75, 78 degrees after the rain started, and then all of a sudden it'll jump up to like 95. And then within the next hour, it's back down into the 70s. So it doesn't last very long, but it's really fascinating stuff, these heat bursts and the collapsing thunderstorms. So the other couple of ways we get winds from thunderstorms are outflow from the storms. So up in the thunderstorm itself, you get a lot of wind, a lot of movement, and so forth. But there's also heating and cooling principles that are going on within a thunderstorm. One of the principles up there is cooling takes place in the thunderstorm. We call it evaporative cooling. So if you evaporate something, the temperature drops around it. So what happens up there is you're evaporating some of the water in the cloud itself, and it generates this pocket of colder air. Well, colder air wants to sink. So that colder air sinks, sometimes hits the ground, and rushes out. And that air rushes away from the thunderstorm. And that's sometimes you can get some strong winds by outflow from storms. Bow echoes are more of when you have a large, kind of like a line of thunderstorms that are moving in one direction. And what will happen is occasionally that line will, what we say, bow out. So remember the old crossbows, and bow and arrow instead of the newer ones where they just have it like this. But the old-fashioned ones with the big arc to it, that's the bow echo. So if you see a radar that has this curve to it, right at the center of that curve are where the strongest winds are located. So if you're ever looking at a radar and you see this big line of storms coming to you, and you're right there in the middle where it's kind of curved out, you're going to get some high winds. So those are bow echoes. The other one are microbursts. And microbursts are basically like the name implies. They're micro, they're small. They happen over a small area. The Cowboys training facility collapse, does everybody remember that? I guess about 5 years ago now. That was caused by a microburst. And they're very, very hard to detect. They happen very, very fast, and our radars oftentimes miss them because they do happen so fast. But microbursts can occur with any type of thunderstorm. Even if it's not severe, you could get a quick burst of wind up to 70 miles per hour. And those are really, really tough to predict and tough to forecast and even tough to see on the radar. So those are our thunderstorm winds. So tornadoes. We have an average warning time of about 13 minutes. That's the average time we have before a tornado touches down and when we see it on the radar. And that's just an average. Sometimes it's much, much less. Sometimes it's a little bit more. Now, the vast majority of tornadoes are weak. They're very, very short-lived, and they're not very strong. The bigger tornadoes are usually the deadlier tornadoes. Those are the ones that are typically on the ground a lot longer. So we actually have more warning time for the more devastating tornadoes. It's the little spin-up tornadoes that oftentimes we don't have much time to warn people because they happen so fast. And oftentimes it may be just a couple hundred yards where that tornado's on the ground, then it's it, and then it's over. But the bigger ones are the more deadly tornadoes, and we have more lead time with those bigger ones. So this is a video we had from our chopper a couple of years ago of a storm down in Erath and Hood County, which is Stephenville, Granbury area. So what you're going to see here is kind of the structure of one of those thunderstorms. And I'll talk through what we're seeing here. But you're going to see where the air is going up into the thunderstorm and what we're watching for rotation. So what you're looking at right here is the rain shaft. Right here is the updraft. This is where the air is going up into the thunderstorm. You've seen the hook echo before on a radar? This is the hook part down here. This rain here is the bottom part of the storm where the hook. There's a little funnel right there. So this whole area is where the air is going up into the thunderstorm, and this whole area is rotating. And within that large area of rotation, that rotation can tighten up, form a funnel cloud, and possibly drop a tornado. So from our chopper, and we were live on the air when this was happening, I was watching this real closely to see, okay, is that tightening up and is it producing a tornado? In this case, even though this storm was really tightly wound up, it never produced a tornado. We never had a touchdown. Even though this whole base was rotating and we had several funnels come up, we never got a tornado out of that thunderstorm. This one did produce a tornado. This is the Trinity River. This is downtown Dallas. This is Mockingbird Lane right here. This was Tropical Storm Hermine. And the real striking image of this is not only obviously the tornado and Love Field sitting about right here. Look how full the Trinity is. Have you ever seen the Trinity that full? These are the levees right here. This is the bridge. I mean, this is incredible. This day was probably the biggest weather day we have ever had in North Texas, because that morning and that night into that morning, we had 8 to 10 inches of rain across the Metroplex. We had the serious flooding in Arlington. Remember the video of the people being rescued on the fire truck ladders from their apartment? There was flooding everywhere that morning. And then in the afternoon, the center, what was left of Tropical Storm Hermine, tracked up right over top of us, and we had a lot of spin in the atmosphere. And so we had these relatively weak thunderstorms that produced these very short-lived spin-up tornadoes. And this one we were watching live on our tower cam as it crossed over the Trinity and was heading towards Love Field, and it eventually fizzled out, and it's starting to happen in that process. But that was an amazing day. There's never been a day that I can recall where we've had so much weather happen in one day. And I believe there were 13 tornadoes that day, in addition to all the rain we saw. And what really, not funny story, but interesting story about the Trinity here. So I get geeked out about this stuff, if you can't tell. So it was amazing because that morning with all that rain, the Weather Service provides projections of river forecast. So later that day, with the data that was coming in with the rainfall amounts and the additional rainfall yet to come, it was actually projected at one point that the levees would be topped in Dallas because of the rain. And that was a scary moment when you think, oh my goodness, the levees which have never failed or never been topped in Dallas could possibly be compromised in the afternoon. Fortunately, it crested at its 3rd highest point ever. It didn't quite get above the levees. But I mean, just how high that river was during this was just amazing. So how many tornadoes do we see a year? Well, we're on the southern side of what we call Tornado Alley. Right here's the Metroplex, obviously, you can see. Just to our north is where the number of tornadoes a year goes up. So what this represents is a 2,500 square mile average frequency of tornadoes per year. So if you were to look at a 50 by 50 mile square, which is basically a county and a half or so, up here along the Red River, we usually see 3 to 4 tornadoes a year. Just here on the northern side of the Metroplex, basically north of I-20, 2 to 3 tornadoes a year, and then lesser amounts, obviously, as you travel south. And along the coast, you'll get some spin-up tornadoes from tropical systems. But we're right there on the southern fringes of Tornado Alley. And oftentimes, there's a huge difference from the weather in Oklahoma to the weather here. And that's just the way it is. Usually, Oklahoma, the upper-level storms that come across the country usually track more over Oklahoma than they do over North Texas. And that's kind of a function of the geography of the United States. So I was mentioning how most tornadoes are weak. Here's kind of a nice little representation of the percentage of the tornadoes. So most of them are weak, the F0 and F1s. This scale has since been updated since '94. It's now called an EF0 or an EF1, but it still shows the same principle. Most of them are weak, about 75% of them. The F2 to F3, about a quarter, and then the F4 and F5s, which are the most violent tornadoes, about 1%. But those 1% of tornadoes cause the most deaths and fatalities. 67% of tornado deaths are a result of those larger tornadoes, and very few are caused by the weaker tornadoes. So with that supercell thunderstorm, just to look at the storm structure one more time, you've got the big storm, obviously. This area here where the air is going up into the thunderstorm, that's called your wall cloud. So right in there is where, if it starts to rotate, that's where the tornado would be located. You're never going to see a tornado in a rain. Now, sometimes they'll be rain wrapped, but you're not going to see the tornado itself form where the air is sinking. Tornadoes form where the air is rising and rotating and spinning. Usually right next to the tornado is where the hail will be. So oftentimes, if you have a storm coming up from the south and you've got a tornado warning at your house, okay, and you start with some rain, so it starts to rain, then all of a sudden it starts to hail, and that hail gets bigger and bigger. Sometimes you'll be right there in that hail shaft where the hail's coming down, and then this area where the air is rising will come over your house, and that's when you could get the tornado. So oftentimes with the track of storms we see here in North Texas, you'll get rain, hail, then the tornado. So if you start to see large hail, and I'm talking really large hail, baseball-sized hail or larger, that's when you for sure want to go to your safe room if you're under a tornado warning, because you're really close to where that updraft is and likely where the tornado is as well. So just make a mental note of that. So the air goes up, it moves out, and then it sinks and it forms the rain. And then this is obviously the area to watch here for a possible tornado. So just a couple storm spotting, and I see I'm running out of time, so we'll go through these real quick. This is a wall cloud. So this is where the air is going up into the thunderstorm, and if this was rotating, this would be the area to watch. A lot of people might see this and say, hey, that's a tornado. Not really, no, because there's nothing here at the base of this updraft that's actually rotating. So you're looking at the wall cloud, the lower cloud base, and you're looking at that lowest point, but there's no tornado there. There's nothing there that's rotating. This is a tough one because this whole thing is the wall cloud, and there's the lowering taking place, and you say, well, that's got to be a tornado. Well, it's kind of inconclusive because you cannot see the ground from this vantage point. So you've got the lowering, but you can't see if there's a tornado on the ground. There certainly could be, you just can't see it from where you're looking at. And a lot of the resources we use here in North Texas when I'm in weather coverage are the storm spotters. And these folks are trained to spot storms and identify what's going on. And they relay that information back to me via ham radio as to what they're seeing and how bad the storm is. So this is an interesting one because how many have ever seen something like this? It's a real nasty looking cloud that's pretty large coming right at you. That's called a shelf cloud. And that's one of those outflow of winds. When it showed you the winds, it's the outflow of winds that's coming out of the thunderstorm and generating some gusty winds. And this happens when you get air rushing away from the thunderstorm. Oftentimes when you see that pass over your house, you're going to get a big burst of wind, and then it will start to rain in a little bit. It's a sign of strong winds. So here's a little video of a tornado. This was April 3rd of 2012. This is our storm chaser, Clint Perkins, talking right now. He's in Mansfield right now, real close to 287. So we had a tornado on the ground here. We obviously had the warning out, and we're on the air talking about this, and Clint will be on the phone throughout this process giving me updates about what he's seeing. So here's that tornado there. And you can see it looks like a relatively weak tornado. You can never really guesstimate the intensity of a tornado by looking at its size. Obviously the bigger ones are the stronger ones, but even these little ones that may not cover a lot of ground can have winds up around F3, F4 criteria. You just don't know because you're looking at it as it's happening. So here's the tornado as it crossed over 287, right near Mansfield.
Large tornado.
That's the same storm that you saw a second ago. There's 287. And this is what's scary about the Metroplex is when we have storms like this during the afternoon commute, it is incredibly dangerous to be on the roads because you get stuck in traffic, you have no place to seek shelter, and something like this can happen. Amazingly, this crosses right over the highway, didn't affect anybody. Everybody had stopped and let it cross. It was really amazing. But look how intense that tornado is now. Imagine how scary that would be to come up on that. And Clint's yelling at these people, get off the highway. What's really interesting about this video is you can see these little things that we call multiple vortices. So you have the general circulation of the tornado, but within that circulation, you get even faster spin-ups. So the whole thing's, and there he's talking to me on the phone. So the whole thing's spinning, but within that spin, there are additional spins that happen. And those little multiple vortices are oftentimes where you get the most damage, because it's like a figure skater that's spinning around. She pulls her arms in, she goes faster. Same principle with a tornado. If it tightens itself up, it can spin faster, and that happens with the multiple vortices of the tornado. This eventually went up towards Arlington and damaged several homes up there in the Green Oaks area of Arlington. So a little bit about winter weather. Remember this from Super Bowl week? What a mess. So that was just a disaster, wasn't it? And it was so funny because everybody's like, oh, that was a horrible winter. It was just so bad. Well, actually, we had about 2 weeks of winter, and it was the first 2 weeks of February. That was it. The whole rest of the winter was actually really, really nice. Unfortunately, it just happened where we had all those, hundreds of thousands of people in town for the Super Bowl, and it wasn't our best moment. But yeah, but you can see that the snow there. So on average, we see about 1.5 to 2.5 inches of snow. This year, we've only seen about 3 inches of snow. We've had all this sleet and some ice and so forth, but we haven't had a tremendous amount of snow. The most ever was the 77-78 winter, which also, by the way, was the winter where we had the most freezes on record. So back in the winter of 77 and 78, we had 62 freeze days. Any guess on how many we are this year? Anybody following me on Twitter, you would have seen yesterday because I tweeted it out. Counting today, we're at 53. And so tomorrow, because we'll have another freeze tonight, will be 54. So we're getting close, and it's possible we'll have several more freezes before we're done with freezes. In fact, the average last date of a freeze in DFW is March 13th. So we've got a few days yet before we get to that average. So I'll just put these up here just to kind of see the criteria. You can read through them if you want, but I've got about 5 minutes here, and I want to take some questions from you all, if you have any questions for me about TV, weather, or anything. Yeah.
What about those, are they mammatus clouds?
Mammatus, yeah.
Are they at the beginning or the end?
They're at the beginning. So what happens is these mammatus clouds are beautiful looking clouds. They're like cotton balls hanging down from the top of the sky. Those are, I'll go back here and show you. So right here. So as the air goes up and the air spreads out, right up here are the mammatus clouds. And that's the air rushing ahead of the thunderstorm. So right up here is where you get the air that kind of oscillates back and forth, and it generates these cool looking clouds. So if you see a deck of mammatus clouds heading your way, more than likely that's the direction that the storm is going as well. Doesn't always happen that way, but you can know that there's a storm nearby that's probably going to be heading close to you. Yeah. Mm-hmm. And at sunset, they're just beautiful to see. Yeah.
I was wanting to ask, I've always heard that whenever the tornado is going on, that it sounds like a freight train.
Yeah.
When does that occur during a tornado?
Yeah, it's so amazing because I'll go out and talk to people who have experienced a tornado, and they all say the same thing. It sounded like a freight train, and it does because of the wind. In fact, I don't have the video to show you here, but the Granbury tornado from last year, when it was on the other side of the lake, I had this guy send me a piece of video. He was filming it, and it sounded like a freight train, and the tornado was probably a good 2 miles away. But because the wind was so intense, it sounded like that. But it's more so if you're in it. That's when you really start to hear it. So yeah, but it's the wind hitting things and just blowing. It just affects our ears. Yeah. Mm-hmm. Yeah.
So just follow up to that question. So why do people say it gets eerily quiet?
Right before it hits?
Right.
Well, it's interesting because if you look at like the structure of the storm, depending on where you are, generally if you're sitting here in the rain, then you get into the hail, then you get into the tornado itself. This here, oftentimes you don't have a whole lot of wind in the hail that's coming down. It'll be more within the driving rain, then you just get hail. And there oftentimes is not a lot of wind in this pocket of the storm, but then all of a sudden you'll get into the tornado. And how this air goes up into the thunderstorm and what generates the tornado, there's air that's coming in where it's not raining. So all the air that's going up into the thunderstorm is coming from an area where there's no rain. So you've got this whipping of air coming out from usually the south or the southeast, but it's not coming from where the rain is. So you don't feel that wind going into the tornado. It's usually coming from another source. So it'll be quiet, and then boom, there's the tornado. Yeah. Good question. Yeah. Back in the back.
Can you talk about the changing pressure as it relates to the changing weather?
Yeah, okay. So basically, because of differential heating on the Earth, and the Earth is amazing because it always tries to find balance. The reason we have seasons is because the Earth is tilted and the sun's direct rays aren't always in the same place. If the Earth was not tilted, if we were just perfectly and the sun was always hitting the equator, we would have perfect weather everywhere. It would be equal balance across the Earth. But because the sun heats the Earth differently, different parts of the Earth warm and different parts cool. So how the Earth works is basically it transfers heat from the equator to the north and transfers cold from the north or from the South Pole back towards the equator. How that happens is because you get pressure. Remember the ideal gas law? Pharmacist, anybody? Yeah? Ideal gas law, P equals rho RT. And so if you change the temperature, you're changing the pressure. And when you do that, you get high pressure, you get low pressure. And low pressure is where we have the storms, and high pressure is generally where we have the nice weather. So that's how that operates. And basically, a thunderstorm is an area of low pressure. It's just a micro area of low pressure because you've got the wind rushing into where the pressure is lower because the air is going up, and that lowers the pressure down at the ground, and that generates the thunderstorm. So everything has to do with pressure and temperature. That's all the atmosphere is, pressure and temperatures. Yeah.
I heard one time that falling on a tornado usually follows lower terrain like valleys.
Yeah.
Is that true?
There's been a little research as to how the terrain affects tornadoes and tornado genesis and how a tornado starts. It's kind of hard to prove, though, just because you don't have enough data coming. Like if you're looking at a particular terrain, well, how often does a tornado actually happen there? So you don't have enough of a data set to say, well, this actually is causing more of a tornado threat in this particular area because of the terrain. You just don't know. But there is some research as to, okay, if a tornado comes across and the inflow that's going into the tornado hits an upglide or a little, the angle of trajectory is just right, will that generate more spin? It's certainly possible. It certainly is, but there's no way to prove it. Yeah. But it used to be believed that tornadoes would never go back down a valley. They would just go up the hill and stay up and be gone. But back in the mid-'80s, there was a huge tornado outbreak in Pennsylvania where the tornadoes went up the hills and right back down the hills and up the hills and right back down the hills. That was the first time it was ever really documented that, oh, wait, they don't bounce over valleys, So, yeah.
Does it hail more here than other places? So why?
Yeah, it kind of does. Yeah, here in Oklahoma and Kansas, it's really because of the motion of the air is a lot faster here in the central part of the plains because of the difference in temperatures that we see from the moist Gulf air coming up from the south, the drier air coming in from the west, and then also the colder air coming in from the north. So you get all these principles together that create really violent updrafts, more so than you would have out east. So the air is rising a lot faster, so you get the bigger hail. Yep.
I always heard that it's not safe to stay in your car because of a tornado on the roadway. But you get out and get in the ditch. And it's also not safe to go underneath the viaduct.
Never, ever do that. That video that came out many years ago of the people running up underneath the overpass to seek protection from tornado is the absolute worst thing you should do. Those people were lucky they weren't sucked out of there because you want to lower yourself down to the ground as low as possible because the higher you are off the ground, the faster the winds are going to be in that tornado. So those people who are up there in that viaduct, if that tornado would actually went right over their area, they would have likely been blown out of there. So you got to think that, there comes a point where the wind is zero at the ground level. So you got to get as low to the ground as possible. So never ever elevate yourself by going up into an overpass. You obviously want to try to get to a ditch if you can. The other thing you have to be cautious of, though, is flooding. You don't want to go into a ditch and then all of a sudden it starts to flood. And that actually happened, yeah, it's very dangerous, yeah. That actually happened in Oklahoma. People went under, the big viaducts when they were underneath the road. Some people went under there and were actually killed because they couldn't get out when the rain came in, the water went up. So, it's really dangerous to be outside at all. Your best advice is to seek shelter in a building as best you can. Yeah. Yeah.
We can take one, sorry, we can take one more question
Okay.
for Larry. Anyone else have a question?
This is a fear-based question. So you were able to identify it was an actual tornado during the daytime because you see it touching down. What about nighttime?
At night, we have, our spotters are still out there, and they look at the lightning flashes. So when you see a flash of lightning, they look to see if that base of the cloud is all the way down to the ground. And that's the only way they can tell. Now, the other way we can tell is if it's hitting like power lines, you'll see an arc of power. That's another way at night to tell if there's a tornado on the ground. Other than that, you don't know. Yeah, that's the scary part about tornadoes at night. Yeah.
Thank you, Larry.
Okay. Thank you all so much. Thank you. Thank you. Thank you very much.
All right, before we get out of here today, real quickly, has anyone noticed these new alert beacons that we've put around campus? I'm sure some of you have seen them. What I want to let you guys know is that if you hear these activated, remember a couple things. Do not assume that they're fire alarms and evacuate the building, because what we will do at the safety office is that we can activate these for any type of hazardous condition on campus. So you may actually need to shelter in place. So for example, for severe weather, if we have a tornado warning, we would activate these for the building, and it would provide a descriptive message with protective actions to take on that beacon. So do not assume that they're fire alarms. If you hear them go off, just simply walk up to them. Again, that message will be on the middle panel, and read the message and then take the appropriate action. We'll also use these beacons to send all clear messages or return to normal operations. So if it's a warning or an alert, this will actually flash red and emit a tone. If it's an all clear message, it will flash green and emit a different tone. And real quickly before we get out of here today, I want to demonstrate that for you. So of course I'm going to have to log in real quick. And so we'll set this off in our room, so RES 100, and we'll set it for, we won't go 2 minutes, but we have to because the system will not allow me to activate it. So there we go. We'll set this off and send. And this should go off in a matter of seconds. They're very reactive to the system, or very responsive to the system. So there you go. And there will be a message that pops up on that center panel. And again, they're very responsive, and that's what we like about them. So. There you go. Does anyone have any questions about those or anything else? I thank you all for your time today. Again, grab some pizza on the way out. There's plenty. And again, thank you for your time.
Thank you, Blake. Appreciate it.
Thank you
very much.
Yeah.
Yeah. Oh, you're welcome. Thank you. Oh, good.